Let us learn about magnetic compass. A magnetic compass or compass needle is used to find the direction of a magnetic field at a given point in a horizontal plane. It essentially consists of a magnetic needle which is placed on a pivot in the horizontal plane. Thus, a magnetic compass can move only in a horizontal plane. When the magnetic compass is placed in a horizontal plane on Earth's surface, it aligns itself along the direction of the horizontal component of the Earth's magnetic field at that point. Or, it can be said that the needle aligns itself along the magnetic meridian at that point. At some places, the deposits of magnetic materials inside the Earth cause the magnetic compass to deviate from the magnetic meridian. At such locations, the angle of declination at that point helps us to determine the actual direction of the north. Let us now discuss the deflection of a magnetic compass placed at either of the two magnetic poles of the Earth. At the poles, the magnetic field lines either converge or diverge vertically. Hence, the horizontal component of the magnetic field is negligible. This means that the needle can effectively point in any direction. Thus, in terms of the path-finding ability, the compass is rendered useless at the poles. In such cases, a dip circle is useful. Dip circle is basically a magnetic needle pivoted in such a manner that it is free to move in a vertical plane. We can thus measure the angle made by the magnetic field with the horizontal plane. In the case of poles, this needle points downward, and as it approaches the equator, the needle aligns in the horizontal direction. Let us now discuss about the Earth's magnetic field. The Earth's magnetism is largely attributed to iron and nickel ions present in the hot and molten core of the Earth. This theory gains force from the fact that the Moon does not have a molten core, and hence it does not have a magnetic field. Venus has a slower rate of rotation and a weaker magnetic field compared to Jupiter, which has the fastest rate of rotation and a very powerful magnetic field. Although magnetism is attributed to these circulating currents in the core of the planets, the energy required for sustaining these currents and the causes for this is not very well understood till date. These are still interesting research topics. In fact, the path of the solar wind, that is, the stream of charged particles emitted from the sun, produces some magnetic field, which interacts with the Earth's magnetic field. Therefore, you can say that the Earth's magnetic field influences the solar wind. The pattern of the Earth's magnetic field is noticeably different at the poles than from the rest of the Earth. In fact, there is evidence that the Earth's magnetic field changes prominently in the short term, which is in centuries, and long term, which is over a span of 1,000,000 years. The dip angle at London varied by 3.5 degrees in a span of 240 years. That is, from 1580 to 1820 AD. This indicates that the position of the Earth's magnetic poles varies its position with time. Hence, it is observed that the Earth's magnetic field has even reversed the direction during long-term changes.